Hi everyone, my name is Rodrigo Laigner, and today I will present the paper, A Distributed Database System for Event-Based Microservices. This paper was performed in conjunction with my advisors Yongluan Zhou and Marcos Antônio Salles. We are currently witnessing the increasing shift of architectural paradigm. Before, we were very used to deploy applications as a single deployment unit. So all the components or modules of application, they would be tied together as a single deployment unit, usually communicating with a single database server or a single database management system. But today, more and more applications are being deployed using the microservice architecture style. In microservices, every functionality can be decomposed into a single and a small and autonomous service. Each one of these services, they may enjoy the proper programming language and technologies, and also their own database system that most fit their own workloads and data formats. In our recent work, we have found that developers are facing increasing challenges on dealing with data management in microservices. Although they are being successful in terms of software engineering, database management data management is still challenging to most developers. For instance, we have found that although microservices are supposed to be autonomous, they often end up needing synchronizations or coordinations. Think about the case of e-commerce. So let's say when we add an item to a cart and the cart is modeled as a single microservice, it's usually the case that a cart add item request needs to coordinate with the stock microservice to safeguard such an item is not taken by another client. But we have found that a lot of developers, they are implementing this concurrency control at the application level, and they end up skewing off correctness. Another case is that at the same time you decompose your application, you also decompose your application state. So we have this idea of a private state that only concerns to a single and individual microservice. So this causes that cross microservice queries are often required because you need to access multiple states. We have found that developers, they often query and join distinct private data for online queries also at the application level. And this is also error prone because it is very hard and complex to ensure that you get a consistent view over the state. Another problem we have found is that even though they are independent, even though they are supposed to be autonomous, sometimes you have functionality dependencies cutting across microservices. Think about the case when you have a products microservice who's responsible for managing products, and you have this stock microservice who's responsible for managing the availability of such products. So this is the case that you have a referential constraint between a product, which is managed primarily by the product microservice, and the stock microservice. And we have found that developers, they have no way to enforce such a correctness criteria at the system level, and they do that, they perform this constraint enforcement at the application level. In other words, they want to avoid dangling records. But the point is that this is sometimes an error-prone process, and they end up resorting to eventual consistency schemes, and sometimes they even skew off this constraint enforcement. Another problem is this interleaving of asynchronous events, because that's the way more and more microservices are using to communicate with each other in order to provide a loosely coupling between them. Think about the case we have basket checkout request, but we also have product price change requests. The point is that in most cases that we have interleaving asynchronous event streams, it's often the case that there's no way to enforce any kind of application correctness. So for example, what is the correct? Processing the basket checkout first, or applying all the product's price change at first. So in most cases, both events, they are arbitrarily processed and there's no way to ensure a correctness criteria. So these are examples of problems, but real-world deployments can get even more complex. So this is the figure that represents the Airbnb microservice architecture. The meta problem is that applications doing data management, and this is very problematic because this is challenging and often harmful. Data management logic should not be oblivious to the database. So this is the outline of the presentation. We presented now the state of the practice, and now we'll move into the status quo and limitations of state-of-the-art data systems. And then I will present the microservice abstraction for database systems, and then an architectural vision. We have identified that, in fact, database management systems, they are designed to interact with black box applications. So what does that mean? That they do not understand what is going on at the application level. That is very hard to understand what is actually going on between this complex interplay among microservices. And these data movements between these microservices, which often occurs through events, through asynchronous events outside of the database. So we need appropriate abstractions to understand what is going on at the application level so we can put database systems at the central role again. So what if we push data management tasks down to the database? Can we do it? We push data management tasks down, but how does that work within the database? We still need some form of an abstraction to map a microservice invariants, or in other words, constraints, and their data management tasks, such as replication, queries, functional dependencies, to an internal representation that the database can effectively manage. So the core building block of abstraction are virtual microservices. A virtual microservice is a construct that logically encapsulates a state of a particular microservice, and also its constraints and external data dependencies. Lastly, a virtual microservice also embodies, encompasses the inbound and outbound event streams of a given microservice. So by mapping these to an internal representation that the database can manage, the database gains knowledge over the event data flow across microservices, the constraints that cut across microservices, and then the application is no longer a black box to the database, which is good. So before digging into our architectural vision, let's first understand how we see this going in terms of the paradigm shift of centralized versus decentralized data management. It is used in most cases, microservices, they prescribe, and it's also one of their benefits, a decentralized data management. The idea of data sovereignty of each microservice, and each chain can effectively manage their own data without having to coordinate with other teams and other applications. But in order to push these data management tasks down, we need, and to correctly enforce these constraints cutting across microservices, we need a global understanding of the application. We need to reason about this global correctness criteria that is exposed by that is expressed by developers at the application layer. So we believe a proper way to do it is through centralized data governance, but it does not mean that we will fail to achieve the data sovereignty or to affect the data sovereignty of microservices. Why is that? So recent developments of the database management area gives us a path to better understand. Multi-tenant databases, they provide strong isolation, and they also centralize a database. Besides, Polystore and DEBS, they provide heterogeneous workloads and data forms, and they are still a centralized database. So the paradigm shift doesn't refrain us from achieving the same benefits microservice architectures prescribe. So let's go back to our cross-platform architectural vision, and let's focus now on the application layer. First of all, we believe the software framework is a compelling abstraction to allow us to understand and control better what is going on at the application layer. Software frameworks, they are an industry-trained approach to invert the control of the application. What does that mean? That we can dynamically introduce logic and control the application. Think about the Hibernate or think about the Spring framework, for example. These are examples of software framework that controls the application in the role of the developer. By having a software framework that will act as a database component outside the database, it'll allow us to understand these external data dependencies. So this is the idea. I mean, as the data is on the outside, we also push the database to the outside. By having a software framework, the application layer, we can enforce these event-based constraints and also control the scaling order of application logic. So let's take a look at our programming declarative constructs. First of all, as I mentioned earlier, we have the card microservice and we have the stock microservice. At the stock microservice, we have this declarative construct called lease. A lease means that I want to lock that an external microservice wants to lock a given set of items or a given item in my private state. So the idea is that I expose some entities and I can declare which entities I want to expose. And I also expose the interface for which these external microservices can contact me. So in this case, the stock microservice is exposing the stock. And this cross microservice synchronization is captured by a declarative construct. This form of declaration is a well-known and traditional way to declare database data management logic at the application layer. And we also take advantage of that. As I said, this is simply interface. There's no need to implement that, and that's how we see that going on. In the COP microservice, we are mapping the inbound and outbound events, which means that the event that is triggering the logic of this microservice and the event that is being generated as the end of this logic. We also have an application-defined isolation level, which we say here is a serializable. And this remote call will respect this isolation level. We also have operations of the private state, and all of that is performed with transactional guarantees. In the end, the queuing of another event is asynchronously performed. Because it's usually the case that some events, they are required to trigger operations in other microservices. Let's move on to more details of this application. Now we have the order microservice. Here, instead of the lease, we have the query. In the query, instead of requiring the locking of some items, we are actually requiring data. So the idea is that there's no need to include error-prone synchronous HTTP requests, and then we still have this data with consistency guarantees from other microservices, which is, in this case, is the discount microservice. So let's move on to how we see the architecture. First of all, this framework will communicate with the database, and the framework is the responsible not only for controlling the application, but also coordinating with the database system. By the time a framework coordinates with the database, it sends a contextual information of the microservice that he is responsible to control. This contextual information is used is used to build a representation inside the database. Also, queries traversing microservices and replication tasks, they are also encoded in a different component called query processor. Async strings, they are pushed to the query processor to push updates, to materialize views and replicate the data items. In the end, a storage layer will map these microservice states, at the same time respecting the data sovereignty principle. The idea to have a decoupled data storage layer is to plug different storage solutions. Here is our architectural vision. More details you can find in the paper. A summary is microservices significantly deviate from traditional monolithic applications. Practitioners then end up employing a lot of pitfalls in the application code. Such practices, they lead to a myriad of data integrity problems. So it's time to rethink how databases interact with fine-grained, event-driven, and stateful services. It is pressing both database abstractions and systems to better serve this emerging paradigm. This was my presentation. Thank you all for watching.